Welcome back, folks. This is Steve, KM9G. They told me it couldn't be done. Actually, they told me it could be done and then didn't do it. Either way, I took it as a personal challenge to make sure that we got this thing up and working and figure out what all is going on with it. Special shout out to Therian for finding the script, and then he doesn't have the hardware, I do, so I was able to verify, run it, and get it all up and moving. So, Wi-Fi and Bluetooth. One of the problems with Wi-Fi and Bluetooth here is that this radio is in a great big metal case. Metal all wrapped around on both ends, and those metal ends and metal top and metal bottom make this thing a Faraday cage. Surprised they didn't know that. But at any rate, that's going to be why we're going to see some problems with Wi-Fi and Bluetooth, and I think the solution to it is to custom fabricate some 3D printed end panels, which would get you some plastic in and out on the left and right, so maybe your signal can propagate. Secondary to that, when we do a teardown on this, you will see that the Wi-Fi antenna is a couple of ceramic surface mount devices. I don't know, but obviously we've got some signal problems, and those would be two things that account for it. I did have to take my USB cable and wrap it in a toroid, wrap it around a toroid a couple of times in order to get rid of some interference. You can tell right away when you plug the cable in and unplug it that there is some noise on the bands. So that helped out a little bit. And then really it's just perseverance. I'm going to go ahead and turn the radio on so that the serial connection is available. Let's see if it cooperates. And I've got the radio running on battery power. And we are charged up to 8.2 volts out of the 8.4 that they say is possible. All right, so now we've got the radio on and running. We've got our serial port connected. This is the exact same setup that I used before. I'm using my MacBook Pro instead of my MacBook Air in order to VNC into a Raspberry Pi, which then has the serial port. This is the same setup that I showed you in the how we rooted it video that you've seen a couple of days ago on my channel. So what is different though is that I've been using this Raspberry Pi so much that I went ahead and configured the environment. I changed the colors on the terminal to be more pleasing to my eyes. I installed ZSH as my default shell. I put OhmyZSH on as a shell enhancer program, and then I put Liquid Prompt on as my prompt. I've done that in a previous video on this channel as well, when I just had to do a quick Linux ham shack build, and that's part of my default install is running all of those things. So we are recording on my MacBook Pro, which is then using the Raspberry Pi through VNC, which we're then going to serial over to the Xiegu X6100. So let's get that all set up. You want to do the same thing that we did before, where we do STTY and connect to the ACM0 serial port with default 8N1 and no parity bit or whatever. But either way, the parameters are on the screen. So that connected up just fine. Then we're going to do screen as a terminal emulator, and I spelled screen wrong. Screen dash slash dev TTY ACM0 with a speed of 115/200. So we're going to connect up to that. And you're going to see a whole lot of nothing because we haven't addressed the radio yet. So let's address the radio. We've now woken the radio serial console up anyway. I'm going to type in the root username, and I'm going to type in the root password. We did crack this password, and then that was sent over on Toad's Discord as well. I will tell you that it was as easy as 1, 2, 3 to crack the password. So now we are logged into the radio. The scripts to start Wi-Fi and Bluetooth were already on the radio. Everything was already configured. It just wasn't turned on, and there's nothing at all in the display on the radio that will give you the ability to interact and set up your Wi-Fi SSID and turn Bluetooth pairing on and put in your Wi-Fi key and connect to devices. All that's missing from the UI. In addition to that, there's some power problems, and in addition to that, there is the Faraday cage. So you're going to see some issues with this. I was not able to get it working with WSJT-X, but you can see that the potential is there, which is what I like about this radio, is there's a lot of potential to hack away on this thing and make it into something better. So without further ado, I'll show you the script, cat/user/support user/share. share/support/USR Wi-Fi is where the script is located. And you can see this is just a typical old-fashioned Linux init script. That directory is in the path. So I can do user Wi-Fi from the command line, and it will start right up. But because nobody's configured this thing, it's going to try to connect to Zygu's Wi-Fi router, which doesn't exist in my house. So let's edit the Etsy Wi-Fi.conf file. I already edited that, so I saved a backup before I did it to show you folks. Wi-Fi.toads. Toads Discord, link in the description down below, where we're talking all about this stuff. This is the Wi-Fi network that they had it set up as in their environment, in their factory, in their laboratory, whatever. So you would change this to my Wi-Fi, and then you would change this PSK. PSK stands for pre-shared key. I was going to say PS key, pre-shared key in this case, not phase shift keying. And you want to change this to my password, and then you would save the file, and you'd be in business. I have already edited this file like I mentioned. Come on. I don't use Vi all the time. All right, so now that's taking care of USR Wi-Fi. And it'll tell you the help file, so USR Wi-Fi start. And it will start up Wi-Fi. It's going to load the firmware for the RTL network chip that's on the board here, which has now been done, and it has found interface WLAN 0. It's initialized the WPA supplicant process, which is what's going to send your passwords back and forth, but it hasn't yet made a connection, I don't think, and it does take it a bit of time for it to make a connection. We'll do IWconfig, and there is indeed no access point yet. And so we just wait longer, or we get really impatient and we start restarting the services. User Wi-Fi restart. And then right when I tried to do that, it said authenticated. IWconfig. And that color change is because of VNC acting up. All right, it says we're associated this time. And there we are, Lakeland Monitoring Station. That is the name of my Wi-Fi access point. And let's try, it just complained again. Are we still associated? Nope, we lost association. And it's trying again. And it says it's associated now. And we are indeed associated again. Do we have an IP address yet? We do not have an IP address yet. And now we have a default IP address because even though it associated with the Wi-Fi, it did not give us a proper IP address. And so this is some of the problems that we're having with the quality of antennas that's in here and a bunch of other things that are going on. So I'm going to switch over to shore power. Turn that on, plug that in. And we're now at 13.5 volts input. And we've now got an IP address. It could be because there wasn't enough power. It could be any number of reasons. It could also be the great big Faraday cage. I'm probably going to say that a lot in this video. Either way, we've got our connection up and running. I'm going to try and ping something through DNS resolution, our old friends at Google that are watching. Bad address Google, ping 1.1.1.1. And we just lost our Wi-Fi connection again. And for all the times I can get this thing to be stable, I have at least 4 times as many times that it's flaky. All right, we are associated again. And we lost our association again, just like that. And we have no IP address yet. Nope. Because we're not associated. I'm going to disconnect the HF antenna. Restart one more time. All right, we've got an association with my Wi-Fi router. And we've got an IP address. And we're now pinging Google. And we just lost a packet. These sequence numbers here should be sequential. So 6, 7, 8, skipped 1, 10, 11, 12, 13, 14, 15, and it's doing pretty well so far. You should really, on a Wi-Fi network, get very little packet loss, but it's trying to go through my Wi-Fi network, through my router, across town to the internet service provider, and then across the backbone to get to Google and back. So let's try something a little more local. We're going to try and ping the router itself. We should have a consistent ping time, and we should have a sequentially incrementing sequence number. We don't seem to be getting any packet loss yet. And the ping times are kind of up and down, but fairly low, 3 millisecond range on most overs. All right, so what can we do with a radio that's got TCP/IP on it? We can sync the clock with the world so that the radio's clock is up to date. Why the radio needs a clock, I don't know. It would actually be more interesting if we loaded an NTP server on here and we synced the PC with the clock after the radio checked something on the radio side of the world and did radio magic stuff with it. This would be better if the radio was the source of truth for the time, is what I was saying, what I was trying to get across. This radio also does happen to have a built-in web server. So let's double check the IP address here. ifconfig, and it will tell me it's .143. And you can see it's going to try to go to HTTP 192.168.200.143. And welcome to Nginx. So this is just an empty web server, but obviously this is a Linux computer, and we can put whatever web server and web server software on it that it's comfortable of running. So there's a big start there. What else can we do with it? SSH root at 192.168.200.143. We put in our super secret difficult password. Now we're SSH'd in and we're running top. So this is my SSH connection, and then this is my serial connection. Okay, so what else can we do? You can see it's trying to run NTPD and get the time from somewhere. You can see that it's maintaining its Wi-Fi config. You can see it's running Nginx, all the stuff that I showed you before. All right, so now we're doing that over SSH. Let's do the Bluetooth stuff. And let's stay on the SSH connection for as long as it appears to be stable. So same thing, cat user share support USR Bluetooth. And you can see this is just a typical Linux init script from way back when. So now we want to run that again with start. And it's going to start the Bluetooth service, and the serial port service has been registered. So this thing exports a serial port for cat control, and it exports an audio chain for audio in and audio out. We've got that running. Let's run Bluetooth D. We're going to have to do everything from the command line because the radio's front panel interface doesn't have Bluetooth D, Bluetooth control. There we go. Let's run Bluetooth control. We're going to run everything from the command line because the radio's screen interface doesn't have any connection details whatsoever on it. We're now inside of the Bluetooth agent, and it is set up as pairable. So let's go up to our screen up here and try and pair it. It shows up as the GSOC BT. So let's try and pair with that. And it says we're paired and it says we're connected. This has been relatively unstable, and I have no HF antenna installed because you saw the problems we had with Wi-Fi. So now I will show you WSJT-X. Oh, that's why. Okay. So let's go into configuration options, and we lost our connection. You can see down here we lost our Bluetooth connection. So let's pair that up again. All right, back into WSJT-X. And where is it getting its audio from? WSJT-X is currently getting its audio from me speaking. All right, so let's do WSJT-X preferences. And radio would be your Xiegu X108G, and your serial port should be one of these two right here, one of these two GSOC serial ports, either CU or TTY, and your settings should be the same. So let's test cat, nothing. Are we still connected? Yes. You can see down here, it says, yes, we're still connected. Let's change this over to the TTY version. Test cat. Nothing happening. Let's switch over to audio page, GSOC BT, and GSOC BT. So the choices that are here, this is built-in microphone built into the MacBook Pro. ATR microphone is this microphone right here. Logitech webcam is the camera that's looking at me that also has a cheesy microphone built into it. VB cable is what you would use for your IC705, and then GSOC BT would be the X6100 because this firmware looks like it was just a copy of that with some other changes put in. The same thing for output. We just got disconnected and reconnected again. Let's see if that's any better. Audio input error has occurred, but do we have working cat control? We do not have working cat control. That's the state of Bluetooth and Wi-Fi now. I've said it a couple of times before, I'll say it again. There is a Faraday cage wrapped around all of this stuff, and there's a whole lot of RF interference that is coming from the serial port and possibly coming down my antenna, but my antenna is far enough away that's probably not what's going on. It's just not 100% reliable, but it does exist, and we, as a team, can make this thing better. This radio is a great platform to play with and tinker on, and that's what I have been enjoying about it. And I've got other videos on tinkering with this radio, probably even one of these over here that you might want to see next. Thanks for being awesome.